So next, look at BubbleSort. So BubbleSort try to find the smallest value on the list, which is we use an array as a list, and try to bubble up. That's what they call. That means move the smallest value up into the front or the low index of the array, and then just push the higher one down. So the first iteration put the smallest elements in the array into the first array position. Start with the last array elements. We compare successive pairs of elements, swapping whenever the bottom elements of the pair is smaller than the one above it. So in this way, the smallest always bubble up to the top of the array. And the next iteration put the smallest element in the unsorted part of the array into the second array position, and using the same technique. And the rest of the sorting process continue in the same way. Let's look at the pictures. So we just look through the array, find the smallest. Right. And we bubble up the smallest. Right, and push the one that higher down. Same, find the smallest. Bubble up. We just higher down until the list is sorted. So let's look at algorithms. So we set the current to the index of the first element in the array, while more elements in the sorted part of array bubble up the smallest element into the unsorted part, which is do the swap here, and showing the unsorted part of the array by incrementing current. Bubble up methods pass the start index and end index. Iterate index going from end index down to start index plus 1. So this start to compare the values. So we said look at end index, right, to the start index plus 1. We start to compare from the index itself, right? Start from index to end index. Just look through the list, and if it's less than the one next to it, then that means the one we compare index to index minus 1. That means the one before it, right? Then we swap. Otherwise, we're good because it's not less than. So current is going to start from, let's look at, it says set current to the index of the first element in the array. Okay, so 36, right? What's next? While more elements in the unsorted part of array bubble up the smallest element in the unsorted part. So we have to look at bubble up now. Start index 0, end index pretty much just 4, right? So for index going from end index down to start index plus 1. So it's similar stuff on the end, right? So now that means the values index is at index 4, right? Which is 6, right? Start index plus 1. So which is, so start index +1 here means that it's going to loop from the bottom to the top of the list, right? One bottom, one top. But when we compare the index, which is the end index, to the previous one, right? -1. So that's why when we look at this, it starts to compare at the bottom 6 and 12. And what's next? So we compare 6 and 12. 6 less than 12. Then we swap. We have to bubble up the 6 up. That's why 6 bubble up. And then we loop again to the current index +1 to 1, right? So current start index +1, which start index 0 to 1. So 6 and 3 do the same. It doesn't have to be swapped because it's okay. Because 3 is less than 6. You go back, right? 6 less than 3? No. Then it's not going to swap. So let's go back to the next one. And also index is also increment, right? So now index change to index 2, which is 3, comparing to start index +1, which is, or index -1, right? When we compare, which is 24. Then we have to swap, bubble up, and then 36 and 3, and then bubble up. We're going to repeating that again, right, with the unsorted part. So let's look at the algorithms. While more elements in unsorted part of array, we do it again. Do the bubble up. Now the bubble up at this point, index going from end, right, to, we can see start index and end index is going to be different depending on the while loop here, which is now start index is 4, end is 1, right? So it start to do that, 12 and 6. Now let's see, it's a value index less than 12 less than 6. So the value at index now is 12. Is it less than 6? No, it's not less than 6. So it's false statement, so it's never swap. Let's skip, so that's why it's okay here. Let's go back to the same 6 and 24. And now 6 less than 24. If you look back, 6 less than 24 is true. Then we swap. So we bubble up 6, and now 6 and 36 is true, and we bubble 6 again. Now you see that if we keep doing this, this is a bubble up approach for sorting. So we're going to have unsorted part, keep doing again, while elements to sort. So we compare 12, 24. Okay, 12 less than 24, we bubble up. And 12, 36 less than 36, bubble up. Unsorted part again, 24 and 36. Then we bubble up, bubble up. And that's why we stop at start, right, down to start index +1. So start index is 3 + 1 down to 4. That's it. So this one just comparing and done. And you see exit loop because no more elements in unsorted part. All blue, this is sorted part. So let's look at the image here, the snapshot of BubbleSort. So we're gonna have the blue, which is a sorted part, and white unsorted part, which is starting from index 0 to current -1, and the current to the size -1, those are unsorted part. Right, 0 to current -1 is sorted part. Now, when we do bubble up, so the current to index -1, this part is not yet examined, and the part that examined are the index +1 through the value size -1. Right, because we start at the bottom first every time, and they are all greater than values index. So this is how we implement in using Java. So just create a bubble up methods, passing start index and end index, and just do iteration index equals to end index, and index greater until index greater than start index, right? And decrement it. So compare the values, index with the index -1. If it's less than, we swap. We already looked at the swap method in the selection sort earlier. So it's the same logic implementation of the swap. Right, just pass index in, put in temp, and replace value 1 of the index 1, and temp put back into value of index 2. BubbleSort, this is a method that just iterates through the whole list, right? Current to size -1. Bubble up is the one who did the actual swap. Bubble up the lowest values up to the list. So we just call bubble up and just keep tracking on the current ++. Very simple when we write down. So look at analysis. You see big O. We see BubbleSort. It's the same as for the straight selection sort algorithms. We have to compare, and then bubble up, which costs n-1 times, and that n-1 comparison for first time. Second time is reduced in the list, n-2, and so on. So therefore, BubbleSort and selection sort require the same amount of work in terms of the number of comparisons. Then if you do add this comparison, you get a arithmetic series, which gonna give you n square as efficiencies. So the next technique we call insertion sort.